For over a century, the global economy has run on a very simple assumption. Things move in one direction. You extract raw materials, manufacture a product, and ship it to a consumer. It operates as a straight line, driven by a take, make, dispose model. Relying strictly on that one-way street is getting expensive. As natural resources become harder to extract and landfills reach capacity, the cost of generating endless waste eats directly into profit margins, while triggering severe environmental consequences. To fix this, companies began developing sustainable supply chains. The strategy was to build environmental, social, and economic responsibility directly into the process. Manufacturers focused on making that forward flow greener. They started ethically sourcing raw materials, working with suppliers who use sustainable farming or fair labor practices, and they optimized their transportation routes to run on highly energy-efficient systems. However, optimizing the delivery of a product is only half the battle. If a sustainably sourced, energy-efficient product still ends up in a garbage dump after 3 months of use, that green supply chain is essentially a false victory. Look at the sheer volume of goods exiting the economy daily. Every year, millions of tons of products are returned, broken, outgrown, or simply discarded. It creates a massive post-consumer vacuum at the end of the line. True sustainability requires a supply chain that doesn't stop at the consumer's front door. It needs the mechanical ability to shift gears and drive in reverse. This is called reverse logistics. It is the physical movement of products and packaging flowing backward, away from the customer and returning to the supplier. Processing these returns operates as the mandatory first step to recapturing physical materials before they turn into permanent planetary and financial waste. Moving goods backward actively fights against the natural grain of global infrastructure. Our warehouses, ports, and software were designed for forward momentum, creating immense operational friction when you try to run the process in reverse. This chart shows the financial breakdown of returns. Adding transportation, inspection, and repackaging, managing a returned item consumes 50 to 65% of its original purchase price. Shipping it back also creates a massive secondary carbon footprint and demands entirely new packaging materials. To make matters worse, warehouses face chaos variables that break standard inventory systems. They have to manually diagnose if a returned item is broken or salvageable, while constantly weeding out return fraud, people sending back stolen or heavily used goods. Reverse logistics is a necessary nightmare. For companies attempting to scale a heavy return system with traditional infrastructure, these processing costs can neutralize the profit margins of the original sale. To handle this friction, modern supply chains are deploying a comprehensive digital patch. By integrating Internet of Things sensors and AI-driven sorting systems, managers finally have visibility and traceability. They can track a single defective unit moving backward through the warehouse maze without losing it in the shuffle. From there, big data and analytics step in. Algorithms optimize return shipping routes in real time, grouping pickups together to sharply reduce the carbon footprints that plagued older manual logistics models. These digital tools form the precise architectural framework required to wire the end of the supply line completely back into the beginning. Merging forward distribution with efficient reverse logistics creates a closed-loop supply chain, a seamless circular system. Inside this loop, companies execute high-effort product recovery. They recycle dead products into raw elements and remanufacture worn-out electronics, rebuilding them to factory-new condition. Dell currently runs an expansive e-waste recycling program to mine old computers for plastics and metals, while Caterpillar routinely remanufactures heavy equipment components like transmissions, saving thousands of tons of steel. Other firms focus on lower friction recovery, like refurbishing and direct reuse. Patagonia actively buys back used clothing to repair and resell, while Nike operates a shoe collection program that grinds old sneakers into materials for athletic surfaces. The most advanced circular model is product as a service. Instead of selling you a piece of hardware, a company rents you the use of it. When it breaks or requires an upgrade, they take it back automatically, guaranteeing the return of their materials. A closed-loop supply chain converts post-consumer waste from an expensive disposal liability into a reliable source of raw materials. This shift leads to a regenerative economic system. In this model, products are designed from day one for disassembly, engineered to stay in use as long as the materials hold together. The immediate corporate incentive to adopt this is compliance. As governments enforce stricter environmental regulations regarding waste and emissions, circular systems allow companies to cleanly sidestep costly fines. The long-term economic benefits become clear through the data. By recapturing value from existing materials, manufacturers slash the need for expensive virgin resources while building customer loyalty through repairable, sustainable product options. Companies stuck operating on a traditional straight line are highly vulnerable to resource shortages and geopolitical supply shocks. Circular companies build resilience right into their architecture. Businesses positioned to dominate the 21st century are those who master the return journey, extracting maximum value from every single atom.